All right, so in this equation here, you want to solve this equation out. As you go through the course, especially next semester, it's going to be important that you know what kind of equation you're dealing with. So again, in this particular case, what kind of equation am I dealing with? Linear equation. And you just so happen to see that this linear equation has fractions with denominators other than 1. So when you see something like this, what does this need to do? Okay, so you got to find the least common denominator, and you want to use the least. You can use any common denominator, but the least is the better one to use. What's the least one? 12. All right, now, a couple ways we did this. One way was, the first way we did it was we put this in parentheses and multiplied by 12, and then we saw that basically what you're doing is you're multiplying every fraction that you see by 12. So if you look on the right side, that side's easy. How many terms do you see? Just one. So you're going to say times 12. Now on this side, think of this right here as one fraction and think of this as the other. So there are really how many terms to think of in this case? Two. So altogether, how many terms? Three. So I'm going to write the first one. You're going to say times what? 12. Write the second one. You're going to say times what? 12. You're going to write the third one. Times what? 12. So that's what I needed to see. So on that worksheet that you have to turn in, the second one, the one with the fractions, I need to see something like that. Okay, so remember it says show work as presented in class. All right, so if you don't show the work, I really don't know what your thought processes are. So I need for you to show something like that. Then what was the next thing you had to show me? Well, even before you do that, you had to reduce, right? Yeah, that was the whole point of multiplying everything by the LCD was to make these denominators what kind of numbers? Ones. Well, they are whole numbers right now. You meant to make them a 1, right? 4 and a 4 is 1. 4 and a 12 is 3. That's what you have to do next. 6 and a 6 is 1. 6 and a 12 is 2. Okay? Now, look at this part right here, and we had a discussion about something like this the last class period. Mistake some of you are going to make is you're going to say 3 times 2x is 6x minus 5. It's not minus 5, it's minus what? 15. So to be on the safe side, one of the other things we talked about was to put this in parentheses right here. And then you distribute the 3. So 3 times 2x minus 15. Okay, now what do I get over here minus what? 2 equal, what's this? Negative 12x. Okay. Then what was the next thing you're going to do? So this was on your first test, at which you will have something like this. What's the next thing you're going to do? Combine like terms. What do you get? 6x minus 17. Negative 15 and negative 2 is a negative 17. So you get 6x minus 17 equal negative 12x. All right, so that's where we're at. Now, what's the best way to go from here? Say it again? Okay, so the next step at some point would be to bring the variables one side, constants to the other, right? So it doesn't matter which side you bring things on, but make it a little bit more efficient for you. What might be a better approach here? So you want to bring the variables to the right side is what you're saying? To the right side?
Yeah.
Okay. So am I going to add 6x or subtract 6x? Subtract. Adding 6x is not going to help me. 6x plus 6x is 12x. So you're going to subtract 6x. So subtract 6x. Oops. And so when I combine like terms, 6x minus 6x is 0. What's left over here? Equal? Negative 18x. Good. A negative 12x and a negative 6x is a negative 18x. One more step when you're done. How to get the variable x by itself? Huh? Divide by what? Negative 18. So I'm going to go ahead and rewrite this over. So divide by negative 18 on both sides. And you got to remember that a negative divided by negative is a positive. And a negative 18 divided by negative 18 is a what? No, it's not. It's a 1. 1 times x is x equal a positive 17 over 18. Okay. Now, let's go back over here. I'm going to go ahead and rewrite this step over. So, and this is the approach I would have taken, but some of you may have, you see that negative 12x? You may have brought the variables to the left side. That's fine. You just got to remember what to do at that point. So, for some of you that want to bring the negative 12x to the left, would you add 12x or subtract 12x? Add 12x. Okay, good. You're going to add 12x to both sides. And combine like terms with 6x plus 12x. 18. All right, good. So on the left side, you get 18x. Tell me what you write. This is where some of you are going to mess up. Tell me what you write. Minus 17 equal 0. Good. Because negative 12x and 12x is what? 0. And then you just got to get the variable by itself. So what's the next step? Add 17 to both sides. And then combine like terms. So I get 18x equals 17. And then one more step when you're done. What's the next step? Divide both sides by 18. And then 18 divided by 18 is 1. So x is 17 over 18. So just notice that depending on what approach you took, you still get the same answer. You just got to be careful with this little part here. So it equals something. You just can't leave it blank. It's got to be 0. Yes?
Okay, I have a question. What were you doing on step 2?
Step 2. What do you mean by step 2? Here,
Yes, sir.
multiplying everything by the LCD to get rid of the fractions. Okay? All right. Now let's go to number 2. So number 2, we have this equation. So we have 3x minus 2 plus x minus 8 equal 2 times 2x plus 5 minus 3. Okay, so what's the first thing you're going to do?
Get rid of the parentheses.
Okay, so use what property? Distributive property. All right, so I'm going to just go ahead and rewrite the left-hand side. So I get 3x minus 2 plus x minus 8 equal, and then 4x plus 10 minus 3. All right. Then what do? Combine like terms. So on the left side, what do I get when I combine like terms? Yeah, 3x plus x is 4x. Nope, a negative 2 and a negative 8. Minus 10. It's okay. You get 7 on the other side. Yes, you do get that. And so 4, and that's equal to 4x plus what? 7. All right, so that's where I'm at. Okay? All right, now remember, you're trying to solve this equation, right? So you're trying to find out what values of x will make, in the original equation, will make the left side equal to the right side. So we're doing some processes to get to that point where we can figure out what the solution is. So what would you then do at that point, at this point? Subtract 4x, okay. Now notice what happens when I subtract 4x. Right, so when I combine like terms, the variables disappear. And so on the left side, what's left? And on the right side, what's left? 7. So the variable disappears. But what do you notice about this statement that I just wrote? It's not a true statement. That's a false statement. Negative 10 does not equal 7. So you may remember in a previous course that when the variables disappear, for linear equations now, you're either going to get no solution or all real numbers. So here, that's a false statement. So can you tell me what values of x will make the original problem a true statement? Is there any?
What'd you say? Ask the question again, I'm sorry.
Can you give me a value for x that will make the original problem a true statement? No, that's a false statement. So what I want you to think about is this. Do y'all agree that 4x equals 4x, right? So if you have a balance, think of high school chemistry, wherever you have that scale, the balance scale. So I have 4x and 4x on that platform, right? Is it still balanced? Okay. So on one side, I'm subtracting -10 from it, right? So it kind of does this. Then on the other side, I'm adding 7 to it. So is it balanced at all? No, it's not balanced. Okay, so this equation is never going to be balanced. So there's no solution. So whenever you get a false statement, the variables disappear. You get a false statement, there are no solutions.
What if you get the same number?
We're going to do a good question. Her question is, what if you get the same number? All right, we'll see. All right, so you're going to say no solution. So in my math lab, when you get to my math lab, there are some problems where you're going to have no solution for your answer. So you do the work, the variable just goes away. If you end up with a false statement, no solution, okay? All right, let's look at number 3. Number 3, suppose I had this. Suppose I had 5 minus 3 times 2x minus 1 equal -2x plus 2 minus 4x plus 6. All right, so 5 minus 3 times 2x minus 1 equals -2x plus 2 minus 4x plus 6. All right, what's the first thing you're going to do? Right, distribute the -3. Now, don't make the mistake. At least one of you will do this, and you'll be very upset with yourself. Don't make the mistake of saying 5 minus 3 is 2 and then distribute the 2. You know, you can't do that. Because according to the order of operations, see, this is multiplication right here, and this is subtraction. According to the order of operations, you do what first? Multiplication. So you can distribute first. All right, so you can get 5 minus 6x, and then what?
3.
Plus 3 equal. And then I'm just going to go ahead and rewrite the other side. All right. Then what? Combine like terms. So on the left side, what do you get? -6x plus 8, or you could have said 8 minus 6x, right? Doesn't matter. -6x plus 8. We tend to put the variable first. Equal on the other side. Plus 8, right? Yes.
When you do the distributive property, 3 times a -1 is a -3, right?
-3 times a -1.
Oh, -3, I'm sorry.
Yeah, keep the sign.
Okay.
Okay, now, if you go a little bit further, what was that? Okay, if you go a little bit further and you bring the variables to one side, what would I do? Add 6x. In fact, you could have stopped there for all purposes because you're trying to find the solutions, right? So at that point, what do you notice about the left and the right-hand side? They look identical. So you would say all real numbers. Yeah, you would say all real numbers. Now, if you went further, though, then you could have stopped here because you can notice the left side does equal the right side. So think about it. If I let x be 1, look at this carefully. If I let x be 1, what's -6 times 1? -6. -6 plus 8? What's -6 plus 8? 2. What's -6 times 1? -6 plus 8? 2. So 2 equals 2, right? So that means that x equal -1, I'm sorry, I said 1, right? X equal 1 is a solution. Let's try 2. If x is 2. What's negative 6 times 2? Negative 12. What's negative 12 plus 8? What's negative 12 plus 8? Not 4. Negative 4. And you do the same thing here. Don't you get negative 4? So is x equal to a solution? So 4, you have how many solutions? 2. How many do you think there are? An infinite number of them. You could use decimals. You could use fractions. You could use negative integers, positive integers, and so on. So I just showed you that so far you've had 2 of them. There's an infinite number of them. But you can look at this and notice that the left side equals the right side. So the solution is going to have to be any number I plug in. Now, if you did go further, though, remember how we went further here? And you got a false statement? So if I add 6x to both sides and combine like terms, what do you get over here?
8.
What do you get over here?
8.
Or is that a true or false statement? That's a true statement. So that means that any number you plug in for x, the left side will equal the right side. So you're going to say all real numbers. So I just tried showing you that at least you can see that these 2 are solutions. If you let x be negative 2, would that be a solution?
Yeah.
Yes. And you can see it will be, because when you plug in negative 2, isn't that the same thing as that? So negative 2 has to be a solution. If you let x be 1/4, I'm not going to plug that in there, but if you let x be 1/4, is negative 6 times a fourth plus 8 the same as negative 6 times a fourth plus 8? So 1/4 is a solution. Okay? All right, so in my math lab, you're going to see some problems where you're going to get no solution or all real numbers. Okay? All right, so that's going to take care of that section.